whoops, sorry. So we were asked to come and share with you this morning a little bit. And I know there's always a lot of questions about math. And we talk about new math. And in reality, math hasn't really changed, but the way that children learn math, the way we attempt to make them comfortable with it and see it is what's changed over the years. And I was thinking back when I was in school eons ago, my parents talking about new math. So it's interesting to, really you want to help your children, you want to understand it. And in this amount of time that we have and our format, we want to give you, just a little taste of how your children are learning math. And then the good news is that we are far enough post-COVID that we again are going to be able to offer our parent math workshops. We had done that before we had to stop, limit people coming in the building. So this fall, and we'll see those dates later, if you really want to understand how things work and what your children are learning, we're going to invite you to come into the building and actually do some of those things with us. So as I think many of you know, for the last 10 years or so, we've had the standards that we've had now in Connecticut for math. We've approached those standards through a Singapore math approach. And basically what that is just a group of research-based instructional strategies that Singapore pulled together in the 80s and from all different countries who had different successful approaches and kind of bundled them together as a way to look at how children learn and teach math. So we're going to share a couple of those real game-changing ones with you and then show you in each grade level how those are taking place daily in your children's math blocks. So the first one, which is a real game changer, is what we call the concrete pictorial abstract approach. And that one actually is an American approach. It came from Jerome Bruner from Harvard. And the concrete part really isn't new because we've always had small children moving concrete objects to learn about number. And the abstract, of course, isn't new because most of math that we do going through life is abstract. But the part that's the real game changer that you'll see and what we're going to show you that the students are doing is that pictorial part. And what that really means is that you can visualize what's happening with numbers, because you have to remember numbers are really just adjectives. So if you have 4, it's 4 of what? And when we're manipulating numbers, we forget really what they are, and it's very abstract. And for children to manipulate those, they think, well, there's just procedures. I just do this with numbers. But if they're really understanding it, they're picturing what's going on and they can do powerful things with numbers. So what we're always trying to do is not teach children how to get answers, or we say teaching answer getting, but we really want them to learn the mathematics, because if they really understand the numbers and are learning the mathematics, then they can build on that and become really powerful mathematicians. So if you think about when you're reading, when we want to increase children's reading comprehension, or when you're reading, you're always picturing and visualizing what's going on. If you can't visualize it, you don't really have a good understanding. And it's the same thing with math. The difference in math is that sometimes we get confused and we think if we know the structure, we follow the procedures, we're getting answers correct, so we're really doing math. And an example that we like to give to really illustrate that, I'm going to do with you here. And we have this little sentence, and you might think, wait a minute, I thought this was a math presentation, and now it looks like it's phonics or something, but stick with us. So we have this sentence, the bulgy chinsels slotted praisily over the flubbish wub. And you may read that and you may think, I have no idea what that's talking about. See, I knew this new math was crazy. Sorry, so just hang on. So if we gave you a little quiz on this, I can guarantee that all of you would get 100%. All right, you ready? Here's the first question. What did the chinsels do? All right, you don't have to write it down. You can sort of answer to yourself. And if you answered they slottled, you are correct. Excellent job. Second question, how did they slottle? Ooh, they slottled praisily. If you thought praisily, you're doing great. Keep going. Next one, where did they slottle? All right, think carefully. Oh, if you answered over the flubbish wub, great. Last question. What kind of chisels were they? All right. They were bulgy. 100%. I bet most of you got 100%. And you're so great. You should go on to advanced chisels. You should be accelerated in chisels. But really, do you understand what chisels, like how much understanding do you have of that? You could follow procedures, the structure of the English language. So you could be really successful, but your understanding of chisels, I would guess, still has some holes in it. So you're great at the answer getting, but that learning mathematics, or in this case, learning chisels, may be lacking. Because if we ask you, would it be easier for those chisels to slot in summer or winter? All of a sudden you're like, wait a minute, I don't see that there. You didn't teach me that. I don't know that. What is it? And you're like, ooh, so now we know how much understanding there really is. Now, if you could picture chisels, if you really understood them, that would be an easy question, right? And some of you have probably been trying to picture something, and some of you might have little furry things, some of you, who knows? Because they don't exist, it really doesn't matter. But if they did and it was real, and you could understand, I could ask you almost anything about them, and you would feel comfortable at least giving an answer, even if you have to test it out. So that's one of the things that we really try to have the children do, is be able to understand it, to see it, to visualize that. And that's one of the strategies going through. And Kelly's going to talk to you about a couple other kind of key ones before we go to the kids' pictures.
Good morning, I'm Kelly. So this shows a picture of basically the framework of what our math curriculum is based on. And at the center of it is our problem solving. We really want math to have context, and that's where they need to take math as they grow and learn and grow up and put it forth in their future. So it's all about the problem solving piece. At the basis of all of that problem solving, we have the three pieces of the skills and the concepts and the processes that they do. And we feel very strongly that through that concrete pictorial approach, that we're kind of building those foundations for them to be good problem solvers. So the unique part about this framework is the top, the attitudes and the metacognition, that we feel really plays a very important role in developing our students as mathematicians. So the first one, the metacognition, is for students to think about their thinking. And when they're really young, they just are going to say, I just knew it, or my brain told me I knew it. And it takes some practice and some experience for them to develop and be able to communicate what their thinking actually is, which will help strengthen them as a mathematician. So we want to build that, so things you can say is like, well, how do you know? Or how did you get that? Asking not just right, great, but how, or, explain it. So that's that metacognition piece that we really want to build with them. That plays a huge part into their attitudes, because we want students to develop themselves as mathematicians and believe in themselves. Everyone can do math, so we want them to believe in themselves and have those positive experiences. Math can be fun and math can be really challenging. So if we have the skills and the concepts and the thinking behind it, and we can have a positive attitude, instead of saying this is hard and breaking down, we want to say, this is hard, like what other strategies can I try? Or, this might take me some time, or I don't get it yet, but I'm going to still practice, their attitudes towards it. And then celebrating when they do really get it and have that. And that's where I feel like every adult in their life, their attitude comes into play, because we want to promote that positivity. One of the biggest things that we always share with parents and, socially, that we would never say like, oh, I'm not a reader. I don't really know words. We are very easy to say, oh, I'm not a math person. I don't do the numbers. We want to take that like off the shelf, because every student can, and with every experience, they can build and learn, and they can do math. So we want to build that positivity from home, from school, everyone who's working with them, to know that their attitudes towards everything really counts and their mindset really counts. So that's a big piece of growing as a mathematician. So I'm just going to show you some examples next about what our students are doing and what math looks like at Hurlbutt. So go ahead, Carolyn, we could go to the next kindergarten. So here is a kindergarten slide, and our kindergarten piloted a program called Methodology last year, and it's in full implementation this year, and we are loving it. It's going wonderful. So just to point out a couple of things here, we start the year off talking about a number and really diving deep into what Carolyn talked about, what a number is, and having them develop have those experiences to really learn. So one of the greatest pictures is the one right in the center. So these kindergartners are having the physical experience of learning about numbers and making sense of them, and they're working together and they're talking about it. So in this case, this number line that they're building, they are kind of placing numbers, and to have the thought on where they should put the number 3 on that number line takes a lot of, knowing what is the number 3 and where is it in relation to other numbers. And these physical experiences is helping them so that they will be able to visualize, as they're not going to have a number line the size of their classroom when they move on, but they're going to be able to visualize a number line that can go anywhere, like into negative numbers anywhere they want. So they're doing things. They're also working in different ways. The group on the left they built that hundreds board. They figured out where every single number from 0 to 100 and how they relate to each other. And they're noticing patterns, and they're seeing like, oh, if I go down this whole row, look, there's all these 2s. There's a 2, there's a 12, there's 22. They're noticing things. The kids on the top, they're doing a number line, but it doesn't start at 1 or 0. It's starting at 11. So that takes, that kind of shift there where they're having great experiences, especially now in the fall, doing some sorting activities. So the leaves have been sorted. They're, making math relative in their life. They're working independently. They're recording in their notebooks. And when you come in for conferences, I hope you get to really look through those and see all their great work. And then the bottom is just a picture of what is the number 4. We see it as the digit, we can see it as on the dice, we can see it in tally marks, we can see it on our fingers, really be able to know what is the number 4 in every context that they possibly can kind of put in their toolkit. So we're working very hard on the concrete and developing the pictorial piece of their math, and getting them to ready for that abstract piece. We'll move on to first grade. So here's our first graders. They are working on number bonds and what is the number that they can, and how can they break it down and how can they show it. So we have students working with the linking cubes. The number bond is that picture with the circles. So the number 8 can be broken down into a 6 and a 2. The picture to the right with the blue and green beads, the number 10 is like the magic number. Our whole number system is based on the number 10, so they are seeing all the ways to make 10 and what 10 looks like and showing it. They're playing games to develop. They're talking about their numbers. What do you see and how do you know? And getting them to talk about it all. And again, the concrete, the pictorial, the abstract is there, and they're working very hard through all that. Second grade is doing, there's some fun things to show here. So the bottom picture shows students working through adding with regrouping, which usually where the new math piece pops up. And so we talk about some really strong math language there, but you'll see some students showing it and building it through with our blocks. There are students who are drawing a picture of what the number problem would look like. And there's students who are solving it abstractly with the algorithm, and they're doing the regrouping. The students on the top on the right are playing a really fun game called Salute. So I hope that your kids will come home and say, oh, well, let me teach you this game. You could play this at the dinner table, and show you how to play a game of Salute. The picture on the left I included because we talk a lot about open questions, and instead of just asking a student, what is 8 + 2? What is 5 + 5? But this asks them so the answer is 10. What could the problem be? And they're thinking, their mind is racing of different ways to make 10. And it could be a number sentence, or it could be a story problem. There's 6 apples and 4 joined them. And how many apples are there? They're developing their own problem solving in the number 10. The bottom with the 43 is really developing their understanding of decomposing numbers, because that's laying the groundwork for their regrouping that they're doing right now. So 43, yeah, it's 4 10s and 3 1s, but it's also 3 10s and 13 1s. Did I say that right before? 4 10s and 3 1s. It's also 3 10s and 13 1s. So it's that number bond moved to a much larger number, and for them to understand the regrouping. We don't just cross out the 4 and make it a 3 and cross out the 3 and make it a 13. Why? What does that even mean? Because they're not going to be able to apply it or use it as they develop if they don't know why and understand it. And we're also working a lot in 2nd grade about their math facts strategies. We're not memorizing facts, but we're really learning some strategies to apply so they can continue to use those strategies in the upper grades and WIS and middle school and moving beyond there. So I'll hand it over to Carolyn for her to share about WIS.
All right, here's our 3rd graders. So this is like a day in the life of WIS on Monday when I was running around taking some pictures. And here's our 3rd graders, one class I went into, and they were adding. And one of the ways that we do add is using place value. And you can see some similarities to 2nd grade. The little boy with the bottom is his job in the group is he's building it. And the larger squares represent 100. They're made up of 100 little cubes that you see on the right of our ones. And then 10 of those cubes stacked together make 10. Those are in the middle. So working with place value, he's adding that number together. The upper left, you see the little girl holding that, is one of the things. It's great to understand the place value. It isn't that efficient when you always have to build. So we want to build first, which is concrete, but we're building to where they can picture those concrete materials. And one of the ways we know they picture them is they can draw them. So she has the hundreds drawn as the larger squares, the 10s drawn as the longer bars, and the little ones on there. And they understand that that's what's represented by the numbers, and that's what you see on that final chart on the right. So all of those 3 representations, I loved this one when I walked in because you could see the concrete, the pictorial, and the abstract all happening at the same time with the students talking about that, because we love concrete, but we don't want them to stay there forever. You're not going to carry your base 10 blocks around with you when you go to college so that you can add, but building that picture and really building the strength was there. Moving to 4th grade, our 4th graders are starting to learn how to multiply larger numbers now. And you can see a few things in place. With multiplication, there's 2 ways that multiplication really is shown. One is equal groups of numbers, and the others are kind of rows and columns, like an array, or how using the area. So the little girls on the right, they're looking at that number 32 times 4, and they're modeling it the same way with the base 10 materials, because they can build 32 and show it 4 times, and they can see how those 10s go together to make hundreds, and really understand how that's going on. Then in the middle, similarly, those little green chips you see there are not ones, but they're the 4th graders also have the chips that are the same size, but are different color and have amounts on them. So they have 100 stamped in the middle of all of those. And they're starting to see how if you have 400 times 2, why is that 800? We don't want to say to them, just multiply the first digits and then add all the zeros on the end. Like, is that easier? Yes, a lot of things about a procedure could be easier, but if they don't understand why that works, which I would venture to guess many of us didn't when we first learned that rule, when there were a lot of zeros, but they actually are building 400, two groups of 400, and seeing the 800 initially. And after doing that, they're realizing the pattern. Oh, that first digit, if I multiply those and then multiply by the hundreds, that works. And then they really own that. The boys in the upper left are playing a game that reinforces their multiplication facts. They have dice that they're rolling, but they also then are building, it's called the real estate game. They're trying to get as much area as they can from that board. And they're using the other visualization of multiplication, which is rows and columns. And area is really a great one to understand deeply, because when you're multiplying larger numbers, using an area model to do that can be very efficient, as well as being able to understand conceptually. And the bottom left, you see some students who are discussing a problem, and they're multiplying a two-digit number using area and solving a problem that way together. So they're using their metacognition. You can almost see in there that they're having discussion, they're proving things to each other, so they're justifying their thinking, but it's also very visual, so they understand what's going on. And then follow that to the fifth grade classrooms down the hallway. On the same day, they're multiplying much larger numbers and dividing numbers and putting those together into the order of operations. So on the left, we have some girls who had a problem. I kind of typed it out by it. They had the class had 8 plus 12 times 2 minus 6. And the problem that they were given was, this was in Miss Linfield's class, and she said to them, Mrs. Linfield did this problem and got 34. Miss Verdi did this problem and got 26. How did they get different answers? Which one is really correct? And then after they were figuring that, because they're looking at an order of operations in math, there's some things that if we don't group them with parentheses, there's certain operations that we do first. And so to look at that, like, what situation would Miss Verdi's number be correct? What situation would Miss Linfield's be correct? And they're figuring those things out together, talking about it as a group, and then they'll look at what situations would each one be correct for, and how do we show that as they bring in parentheses. And so they're really getting an understanding. We're not just saying like, oh, PEMDAS, parentheses, exponents, and they're following a procedure, and they're getting a good understanding. And then the problem that you see from a student's practice book there, I love, because when you first look at it, it doesn't jump out to you what's going on. But when you look at that problem, which is, a good problem for a fifth grader at this point, the grocer has 49 boxes of strawberries. Each box contains 75 strawberries. You can see how this student is trying to picture that by the 75, 75, 75. But they know they're not going to draw that 49 times, so they have a little 49 and little dotted lines showing that's going to keep going 49 times. And then on the right, they figured out how many total strawberries there are. So the first step, they know they're really getting an understanding of what's going on in that problem. So then when they're repacked into smaller boxes of 15 strawberries, how many smaller boxes, that bottom piece is the way that student has chosen to divide those 3,075 strawberries by 15. And you may be like, well, that's not the long division algorithm I learned, but look how quick and efficient that was for them with that number, if you can see it. And we won't take the time to explain it all now, but that's one of the things that if you come to the intermediate school workshop, I can teach you how to divide numbers quicker and with less stress than any way that you ever learned in school with long division. So that, it's great, because that student in those pieces of their work has really shown an understanding of what's happening in that problem. And, bonus, they're really accurate as well, which we do like and we do value. So all of these things, I think you can see in this fifth grade picture, the things that were developed in kindergarten, our students have had this idea of numbers make sense. I understand them. I can picture them all the way kindergarten, all the way up. And that's been really beneficial to our students. coming out of COVID, and I know that, there's a lot of talk about scores and things, and there's definitely places we want to still do a little building up. But our fifth graders at the end of this K-5 learning experience, you've probably seen nobody did better in our group or in the state as far as how they scored on those standardized tests at the end of the year. And I think a lot of that has to do with our students understood what numbers are. And as we worked really hard last year, to fill in some of those gaps and things, it was all with that basis of numbers make sense. I'm understanding this, and it's not just how to get answers. And, I think that that's really gone a long way for our success. Right. I'm going to turn it back over to Kelly for our final piece.
So how you can help at home. So first, we definitely want to keep that positivity and the positive mindset, talking to your kids. We do so much math every day. Every time you shift your eyes to look at the clock and figure out what time you have to leave for soccer or whatever, you talk about the clock, say, oh, I just noticed, and there's things we do when we're cooking and fractions and money and just putting coins out on the table and sorting them or then naming them. There's things we could do at home. That's just everyday real math. We have a K-5 math site, which you may have seen through the summer math challenge, but on that math site, there's a ton of math activities to do there from the summer math that we'll keep up all year. But there's also other things on there. There's some school to home connection letters. So there's a letter for every chapter that your student is doing at school that just kind of gives you the bottom line of what this chapter is about and some possible activities you could do from home. So that website can be found on the Weston site. And when you go to the school and under academics, it's a K-5 math. And our parent workshops, we're so excited to start these again. So WIS's date is set for November 10th. Hurlbutt, we are working on coordinating with the senior center to make sure that we don't have an overflow happening. So that date will also be in November and will be finalized soon. So we'll be happy to share that with you. The signups will come out. Mm-hmm. And we hope at that time that you'll be able to come and talk about math and ask all your understanding questions, experience some of what your students are doing at school, and kind of create that love for math for you at home too. Thank you for having us today.